All right, this is part 2 in benchmark number 26. This is proving parallelograms. So I want to go through the list here to prove that a quadrilateral is a parallelogram. Number 1, you want to go ahead and show that both pairs of opposite sides are parallel. Number 2, you want to show that both pairs of opposite sides are congruent. Number 3, you want to show that both pairs of opposite angles, highlight that, are congruent. You want to show that the diagonals, they bisect each other. And usually you could figure that out by using the midpoint formula. And you want to go and show that the pair of opposite sides is both parallel and congruent. So when you take care of all 5 of these, you can prove that the quadrilateral is a parallelogram. All right, if you have any questions, let me know. All right, this is example 4, benchmark number 26, parallelograms and coordinate geometry. So for this particular problem, you have the graph quadrilateral QRST, and it has vertices Q, which is -1, 3, R, which is 3, 1, S, which is 2, -3, and T, -2, -1. You want to determine whether the quadrilateral is a parallelogram. Justify your answer by using the slope formula. And in a moment, I'm going to show you how to work this out on GAlgebra. So just give it a minute, and then I'll go ahead and work with you guys on this example. All right, welcome back. This is Charles Cranier. So now I'm at the GAlgebra website, and what I want to do is I want to go ahead with graphing calculator, and this is the slide that you guys will see. Hopefully, it'll work for me pretty quick. All right, so the first thing I want to do is, for example number 4, I'm going to plot these points. So go ahead, put in -1, 3, hit enter. There goes my point. Do the same thing for the next point, which is R3, 1. I'll do the same thing for S, which is 2. Maybe I can just write in S. S equals 2, -3. There's my S, and then my T, I'll just type in T, the capital T for point. That's going to equal -2, -1. I'm going to go back here up to my first couple points and change the name of that, make it Q. I'm just looking at my notes. I'll change the name of this one as well and make that R. Okay, so I got all 4 of those points. I'm going to go into my tools. I'm going to go to polygon. Show more here. Polygon. I'm going to start at my Q and make my way around. Q, there's my R, S, T, and Q. The nice thing about this is that you have your quadrilateral. Do we know it's a parallelogram? We gotta double check the slopes here and see if they're first both of them are parallel. So let's go to measurement. I'm scrolling here. I can see the measure of the slope right here. So it says select the line. It's going to select that line. It's going to give me a measure of 4. I'm going to select this line. And this is also a measure of 4. And so I am not sure how to get it on the other side. Settings. I'm not too sure how to get that on the other side. So my slope for line TQ and SR are going to be the same. So let me see if I have a where I could just edit on here. Let's see. If I could find that. Select objects. So I don't notice anything here on how to edit. So those are my slopes for that. So since they're both parallel, I know that at least the opposite sides are parallel. So I'm going to check and see if this is parallel. So this is negative 0.05. So if this line TS is negative 0.05, then we can safely say that this is a parallelogram because the lines here are parallel. The lines here are also parallel. If you have any questions, you can let me know. Thank you. Okay, one last thing I wanted to mention with this problem was I get to do my text box here. So my text, I can say, make this just a little bit so I can see what I'm writing. I can say line TQ. Is parallel to line, let's say SR. It has same slope. And I can say the same thing for the other one. Line, let's go TS, parallel to line QR, because it also has the same slope. And to be real specific here, it's the same slope of positive 4. And this one has the same slope of negative 0.5. So hopefully you can use this tool. It's fun. It's a little bit easier than to do it by hand. If you have any questions, let me know. Your chance to see if this quadrilateral is a parallelogram. So I encourage you to, you can graph it by hand. You can go ahead and use the slope formula. If you don't know what the slope formula is, you can ask me. You can go ahead and Google it and just put down slope formula. And it'll give you the definition. Apply it, see if the lines are parallel, and you're just going to determine if it's a yes or no, if it's a parallelogram. Or you can use that GeoGebra site and plug in those values and see what you get. So I think that second option is a little easier. Let me know what you think, and good luck on this.